we're gonna be talking about in this video is how to approximate square roots and to simplify square roots. Excuse me. If you remember from the video when we was talking about exponents, powers, and square roots, what we talked about was that you can turn any number into a square by giving it an exponent of 2. So something like 3 to the second power, that's turning this 3 into a square. Or if you got like 5 to the second power, you're turning the 5 into a square. Excuse me. And the square is the answer to this question. So 3 to the second power becomes 9. And 9 is the square. For this one, 5 to the second power, that's 5 times 5, which is 25. And 25 is the square. Now, problems like this are easy when the number is when it's whole numbers, like 3, and natural numbers like 3, 5, even stuff like 10. It's easy to turn those numbers into squares. But let's say you had something like this. .27 to the second power. Well, I mean, it's the same multiplication process, but when we do, the square is not going to be a whole number. It's going to have a decimal. It's going to have a fraction attached to it. So that's what you call the imperfect square, and that's what we're going to be talking about. Do I got the other eraser? Let's see. So again, going throughout the time in your algebra class, you're going to be asked to find the square root of some squares. So for example, you might see something like this. What is the square root of 25? And that's simple. We just talked about this. So this is going to be, excuse me, something like 5. Or you might have find the square root of 9, which is 3. But let's say you had something like this. What's the square root of 18? When you have numbers like 18 and 19, and 40 and stuff like that, different numbers, these are what we call non-perfect squares, because I'm gonna go through this in the video, but we'll see basically when we find the square root of 18, it's not gonna be a whole number. It's not gonna be like 1, 2, 3, 4, 5, 6, up to 9. It's not gonna be any of these numbers. The square root, that is, right here. I don't know what that's supposed to be. Do this. This number is not going to be 1 through 9. So the square root of 18, or 18, is what we call a non-perfect square. So let's look back right here real quick. The square root of 25, that's 5. That's 1 through 9. The square root of 9 is 3. That's 1 through 9. You can even have something like square root of 121. What's that? The square root of 121, that's basically 11. And that's cool, because 11, it doesn't have a decimal on it, and it doesn't have a fraction. But not every number is like that. As you get into, more complex problems. So we got this square root of 18. So how do we approximate what this answer is, what this number is going to be? Well, basically, what we do is we look at what square root it's between. So let's look at some square roots real quick. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36. And so we'll stop right there. And so what this means basically, you know, you take the square root of 36, it'll be 6. 25 is 5. But so we taking the square root of 18. So let's see what number 18 is in between. It look like it's in between the 4 squared and 5 squared. So what we're gonna do, instead of finding an answer, we're gonna set up we're gonna set up an inequality. So we don't know exactly what this is gonna be, and we're not gonna waste time. We're not going, and this is what you're gonna do in your math class. They're not gonna ask you to waste time trying to figure out what decimal this is fixing to be. What you're gonna do instead is say that the square root of 18 is we know it's gonna be greater than 4. So we'll put it like this, between 4 and, let's see, it's gonna be greater than 4. But it's gonna be less than 5. I'm gonna put this in a different number to hopefully, or skill a different color, kind of. So the square root of 18 is bigger than 4 because 4 times 4 is 16. And the square root is again, so the square root of 16 is just 4. But it's less than the square root or 5 squared. You can't keep yawning, boy. But the square root of 18 is going to be less than 5 because 5 squared is 25. And again, if you're not following, don't stress, because we're going to go over a couple of different examples. Let's try another example. So let's say we got square root of 26. What times what will give you 26? Well, I don't know, but we can figure it out by doing estimation. So what's the square root of 25? Let's start right there. Square root of 25 is 5. So we know that the square root of 26 is going to be bigger than 5. This is kind of the same situation that we set up right here. So we're going to start off by saying we already know that the square root of 26 is going to be greater than 5. Right? Because again, the square root of 25 is exactly 5. So if we increase that square, it's going to be a little bit bigger than 5. But at the same time, we also know that it's less than 6 because the square root of 36, again, so the square root of a bigger number, 36, we know that that's 6. So the square root of 36 is 6. The square root of 26 has to be less than that because 36 is a bigger number. So we're going to put 6 on the other end of this inequality. And that's it right there. The square root of 26 is greater than 5 and less than 6. That's the answer. Let's do a couple more examples. Excuse me. Let's say you got Square root of 90. Take this, take me to think about that and then see what you come up with. Oh, but I cannot stop yawning. Crazy. But yeah. Think about kind of what we've been doing over here with this and stuff. The square root of 90. So what we're gonna do is we're gonna finish this little graph right here so we can see something. So 7 squared is 49. That's 7 times 7. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. So what we're looking for is the square root of 90. So if we take the square root of 100, we know that that's 10. So we need to find, look like we need to deal with these two right here, because 90 is greater than 81, but it's smaller than 100. So let's start on the lower end. The square root of 81, which is smaller than 90, the square root of 81 is 9. So we can already say that the square root of 90 is going to be greater than 9. And you know what? I'm going to write it out this way just to make sure that there's no confusion. Square root of 81 is less than square root of 90. Because this, we already know that this is 9. We don't know exactly what the square root of 90 is, but we know the square root of 81 is 9. So we'll put that right there. We don't know what that is, so we put a question mark. And at the same time, what I was saying was, so we already know that the square root of 81 is going to be 9. So if we take the square root of 90, we know it's going to be a little bit bigger than the number 9. But we don't know what exactly it's going to be, but it's going to be bigger than 9. So we put that little question mark right here. Going back over here, so the square root of 90 is your question mark. But we do know the square root of 100. We know exactly what that is. The square root of 100, which is right here, we know what number that is. That's the number 10. So we got two numbers that we can use to kind of put a fence around what the square root of 90 is going to be. And that's kind of how we go about approximating square roots. So this will be our answer right here. Square root of 90 is greater than 9, but less than